he's a new joinee faculty in Department of Computational Data Science and this CSA department, and he works in machine learning and neural network. He finished his PhD from University of Pennsylvania, and then he actually did couple of postdocs, one in Google and I think one in Carnegie Mellon, and then he joined there. Okay. So,
all right. Yeah. So everyone can hear me, right? Yeah. So welcome to CSA and IIC. It's great to see you here. So I will give some overview of this relatively new area of research, and also about our work in this area. So how many of you have had some exposure to machine learning? Okay, so that's great. So did you have courses in your undergrad college, or you did online courses? Online courses, right? So Coursera or something, yeah. And how about natural language processing? 1, 2, 3. Okay, so it's a smaller subset. Okay, so we tend to work at the intersection of these two areas. Okay, machine learning and natural language processing. And I believe you had some exposure to machine learning. There was some session earlier today. Yeah. Okay, so you at least have some background. So if you're interested in learning more about our lab and what we do, you can visit this URL, which stands for mollab.iic.github.io, and MOL stands for Machine and Language Learning Lab. Okay. So the thesis behind our work is can be summarized by this statement, that which is background knowledge is really key to intelligent decision making, right? So we as humans make multiple intelligent decisions throughout the course of our day, right? So even simpler things like, if there's a bottle here, how much force I should apply to lift this particular bottle, right? I already know, how much force will be necessary, right? And, I'm not going to apply lots of force and pick it up something like this, right? And the reason I know how much force is necessary, that's because, I have interacted with these kind of bottles and similar objects throughout my lifespan, and I have built some model about the physics of these particular objects, right? So increasingly we are asking, and this is just one instance, right? So another instance could be, say I'm reading some research paper, then which research paper I should read next, right? So to make those decisions, we use lots of world knowledge, background knowledge, and common sense knowledge to make those decisions, right? And increasingly, we are asking machines to make those type of decisions on our behalf, right? So in some sense, the simpler things that you can, programmatically, you can kind of hand program in things, right? So those things are pretty much done, right? So we are kind of moving up the food chain in some sense, and we are looking at machines to do more and more complicated tasks, right? Which are non-trivial, and which might be hard to program in directly by putting if then else statements, right? So that's kind of the whole thing about machine learning, learning to program from in a data-driven manner, right? So our claim is that to make those kind of intelligent decisions, some of those examples which we saw right now, we need background knowledge or world knowledge. Okay, so to drive home that point, let's say that I have some system which is say trying to read say the newspaper, today's newspaper, and summarize that for you, right? You are all very busy people. So you may not have time to go through the whole newspaper, right? If you get a 2-paragraph summary of today's news, so that'll be great, right? So if there is some system like that, so it kind of came across this particular sentence on some newspaper, right? So it needs to understand, why, and that sentence read something like State Farm stocks tumble along with Berkshire Hathaway, okay? So, so how many of you know what is State Farm? What is State Farm? Is it like a farm, right? Some agricultural farm, right? In some state? Sorry? Sorry, I didn't hear. Government bonds. Okay, so it's a company. It's an insurance company. Okay, and Berkshire Hathaway. Right. So that's again a company, right? So even to understand what these things are, if you have not heard about them before, it's hard to make that prediction, right? So that's a type of world knowledge right there, right? If you did not know what State Farm is, you cannot kind of like, even begin to understand what this particular statement says, right? So now we know that like, State Farm is a company, Berkshire Hathaway is a company, and that stocks tumble along with, that means that like, both are probably publicly traded companies, right? And they are like, listed in some stock market, and their stocks kind of like, co-varied on a particular day, right? So even to kind of like understand all those things, you need to understand that like, there is a stock market, companies are listed in stock markets, right? And they are traded in those markets, right? So all those things are not contained in this particular sentence, by the way, right? You have to borrow all that knowledge like you and I have done to understand this particular sentence. But even once we have all of that, it's still not clear what was that causal relationship for their stock prices to co-vary, right? Anyone wants to predict why, say, State Farm's stock price and like, Berkshire Hathaway stock price kind of change together? Yes.
Berkshire Hathaway wrote an article with a negative review about State Farm.
Okay, that could be one thing, but like, why they should both go down together?
Berkshire Hathaway has shares in State Farm.
Possible.
Being went down, so
Possible, right? Okay, any other explanation? Yes.
they trade in the same market or the same book.
Yeah, so this is an insurance company, and Berkshire Hathaway have like lots and lots of different companies underneath them. That's kind of like a holding company, right? Any other explanation? Sorry? Okay, close. So here is kind of like actually a real life situation, right? So State Farm is this company, right, which is mentioned here. They happen to insure this other company called Heinz, right? Heinz ketchup you may have seen, right? Yes. So Heinz is a subsidiary of Berkshire Hathaway, which is mentioned in this particular sentence. Okay? So what happened is Berkshire Hathaway stock prices went down, right? So that means that like, there's something wrong with the parent company. So the subsidiary stock prices also probably went down, right? And now, something is wrong with these companies, right, which caused their stock prices to go down. So the market thinks that like, many of those losses are going to be pushed to the insurance company because they have to cover all that liability, right? So like, they are going to suffer losses as well. So their stock prices should also go down, right? Now does it kind of like make sense, right? At least we have some explanation, right? And how is that made possible? Because I showed you this, right? Like 2 minutes before, we didn't have any clue, right? Why this thing might be happening, right? So that's what we are trying to get at, right? So if you want to make these kind of intelligent decisions, right, we need this kind of structured background knowledge, world knowledge, okay? So is everyone on board with me in terms of motivation, why we need background knowledge? Yes? So even as like, we as humans, we are having hard time, right? By not having this kind of background knowledge, right? Now think about the poor machines, right? Who don't have the type of experiences that you and I have, that we have accumulated over our lifespan, right? How are they going to make these inferences, right? So we want to kind of like bridge this gap and make this kind of background world knowledge available to machines on a large scale, right? And at the right granularity, right relevance, and right point of time when machines need this type of knowledge, right? So in some sense, like, we want to build something like Google, but for machines, okay? So it turns out that there is no, like the type of broad coverage world knowledge that we are looking after. There isn't like a downloadable link somewhere on the internet, right? So where you will download the whole world's knowledge in this kind of like, say, structured multi-relational graph form, and then you will feed it to your machine, okay? That doesn't exist. So now what will you do? So now, we are convinced that we need this kind of unstructured world knowledge doesn't exist, what will be your solution? How will you go about building this? Sorry? Okay, right? So yes, I say, your requirement was to understand this particular sentence, right? So now how will you go about finding this, building this graph? I mean, I need an algorithm, right? Some way, some ideas. So I don't know what sources we can do. What will be like a simplest thing to do? Maybe expensive, but simplest things.
Make separate nodes and connect to the edges.
Yeah, how? Right, that will be the final graph, right? To create the graph, we need nodes and edges. That's pretty clear. But how will you get those nodes and edges?
And if we get the connection between two nodes through the internet.
How through the internet?
Sir, if suppose that State Farm has insured density, there is a connection.
But there is no connection, right? That connection doesn't exist in the form that you want, right? It exists, right? Maybe like, in some document or something, right? But not in the form that we want, right?
Somehow we get the information.
Right. So that's the how we are trying to figure out, right? Yeah. So give me a way for that how. Yeah. Okay. So like in the past things, we'll also have like maybe like that State Farm and Berkshire Hathaway's stock prices went up together and things like that, right? Right. Yeah. So that's kind of like what our motivation is as well. So along with the growth of the internet and the World Wide Web, there is like lots of unstructured data that's kind of like available on the web in free form, in the form of web pages, emails, blogs, tweets, and all of that, where humans have encoded like the world knowledge that we have about these entities and relationships using natural language, right? We write all those things using like English, Hindi, Spanish, like these natural languages. So we see that as a starting point, right? And there is enormous amount of that type of data, which we call as the unstructured data, right? Because those are written in natural language and computers are not very good at handling them, right? Once you have those data in some database, right? Then we have very efficient algorithms to like, run queries, do joins and everything, right? Very nice. But that's kind of like in unstructured form, right? And there is enormous amount of those as well. For example, according to some statistics, even in one single year, in 2011, like 300 million new websites were added to the World Wide Web. Okay. According to Twitter, which is also a little bit dated statistics, in one single day, 500 million tweets were posted. Okay. Maybe that number is even larger now because this is like a 4-year-old statistics, right? And if you were brave enough to sit down and read all of that, that's going to take you approximately 31 years, right? According to some speed. Now we all know that like, all of this data is probably not very high quality, right? The people post lots of junk stuff that's not useful, but at least there is some good content, like, some fraction of that from which we can extract this kind of world knowledge that we are trying to go after, right? So that's kind of like the goal here. So we'd like to build those type of structured knowledge graph like we saw in the first slide, right? By mining this kind of large unstructured data, which is written in natural language, okay? English, Hindi, Spanish, whatever. So what is to make sure like, we are all on the same page? What do I mean by this knowledge harvesting from unstructured data? So let's say out of those millions of documents from the web, here are 2 documents. One says Luke Ravenstall is the current mayor of Pittsburgh. And the other one says after the death of then Mayor Bob O'Connor, Luke Ravenstall became the mayor in September 2006, right? So any one of us reading these 2 documents will probably quickly infer that there are like, 2 people who are mentioned here, right? One is Luke Ravenstall, the other is Bob O'Connor, and there is a location which is mentioned here, which is Pittsburgh, right? And what else? Sorry? So there is a relationship between these objects, right? These entities. that this is a mayor of relationship. And probably that's not all. Both of them were not mayors at the same time. Bob O'Connor was mayor until his death in September 2006. And then this other guy, Luke Ravenstall, took over, right? So when I'm talking about knowledge harvesting from unstructured text data, I'm talking about identifying what are the entities which are mentioned in those documents, what are their types, right? Are they like people, furniture, active volcanoes, islands of Pacific, their types, what relationship exists among those entities, right? Is it like a mayor of relationship, father of relationship, city located in city relationship, all of those, right? And all of those facts or relation instances, those are not universal, right? So they have certain lifespans. Bill Clinton was president of US from 1993 to 2001. He's not president anymore, right? So we also like to know the temporal validity or the temporal scopes of those facts, okay? So that's the goal. Any questions so far about what we would like to do, why we are doing all of these things, right? Everyone is on board, right? Okay. Also, ask me questions, stop me at any point, right? If you just, it's one way, it's going to be very boring, boring also for me, right? So let's make it two-way communication. So also, these ideas about knowledge and knowledge graphs. So those kind of graphs that we saw earlier are called knowledge graphs, right? Because they encode world knowledge in the form of a multi-relation graph, right? So multi-relation because the edges have types and there are multiple such types in the graph, okay? So these knowledge graphs are not abstract concepts anymore, okay? So from around 2012, 2013, when you search for entities or some questions on Google, you would have seen these kind of panels on the right hand side, right? Is there anyone who hasn't seen this panel? No? Okay, so those are called knowledge panels, okay? And the good thing is that many a times it quickly summarizes the answers that you're looking for, right? So here I was interested in Barack Obama. Now quickly this knowledge panel tells me who are his parents, his children, siblings, where he was born, his height, and so on and so forth, right? Now this knowledge panel is made available from this type of knowledge graph like we had seen in the first slide, okay? So this need for knowledge graphs, you're already basically benefiting from it, right? Through improved web search experience, right? So this is already in play, okay? And in a very large scale, a general thing. But this is not a solved problem, right? So when I search last for Kumbh Mela, I don't see as rich a knowledge panel like Barack Obama, right? Now Kumbh Mela is an important event, right? This is a biggest congregation of people at one place. So I would like to know, when is the next Kumbh Mela going to be happening? Where it's going to happen, when was the last one, how many people attended the last one, those kind of summarization about Kumbh Mela, but that doesn't exist, okay? You can maybe give a search again, but at least few days back when I did, and I periodically do this search to make sure whether I should update my slides or not. Okay, so according to Google, they are still at 1% of this knowledge graph problem in terms of where they would like to be. Okay, so Google with all their technical and financial powers, if they say that they are at 1% of this problem, that at least means two things. One is that this must be a really hard problem, right? Otherwise, they would have made significant more progress than 1%. But the other maybe more optimistic view is there is this 99% headroom for improvement for us to go and contribute something, right? So that's where we would like to make some progress, okay? Okay, so this never-ending language learning project at CMU is one such attempt to read these broad coverage world, web documents, and which are in unstructured form, and generate these kind of knowledge graph structured repositories of knowledge as we have been talking about, okay? So the project, so I was involved with that project before coming here, and we continue to do that line of research here in our lab, and that's why I'm talking about this. So the project has kind of like two complementary goals. So one is to advance a new paradigm for machine learning, okay? And the second is to apply that new paradigm for this knowledge extraction problem, okay? So let me kind of like try to motivate you the first part, okay? So, so one thing is like, probably like in newspapers every day, you hear about like, maybe 2 or 3 success stories of machine learning, right? So it's all over, right? Even to the point that like, maybe on Outer Ring Road, you see like, posters for machine learning specialists, like, their skill sets and all of that, right? Also, if you're not from Bangalore, then you won't get this joke, right? So Outer Ring Road is a road here. But anyway, like it's kind of like pervasive, right? So lots of impact of machine learning. So now you may ask the question, why do we need like, a new paradigm? Like, it's already working well. Why do we break something that's working, right? So one response to that is that like, the way machine learning is practiced right now, right, is very different from how you and I learn, right? So we are excellent learners, right? And so kind of like the way machine learning is practiced right now is that like, you kind of like collect some label data for a particular task, right? So let's say spam classification, right? So you will get label data for that particular task. You will do your model estimation or function estimation on the data. You will get a model out of it, and then you will use that model to classify unlabeled instances, test instances from that point onwards, right? So if you're lucky to have more training data going forward, you will do some periodic retraining and then like, get some improved models, right? So, so that's very different from how you and I learn, right? So our learning started right from our birth, maybe even before, right? So it probably, even the womb itself, it starts, and it's going to continue until we die, right? So we don't learn in kind of like a fixed period, right? That like, our learning is going to happen only in this period, and after that, we are just going to use whatever we have learned going forward, right? So the idea here is to have a persistent software individual which learns over extended time horizons, right? So not just kind of like a fixed blocks of time. The second is it should learn many different functions, many different types of knowledge over this periods of time, and also probably at the same time, right? So one example of that will be that like, if I'm say learning how to drive, right? So if I'm learning how to drive, the fact that I can read, that's very helpful, right? That's a useful skill, right? Because what can I do using reading? I can read those signboards on the side, right? Or I can like, read the GPS, which is trying to guide me, right? Now, I did not learn how to read and write when I was starting to learn driving, right? I went through entire school training, and I'm using all that knowledge that I've accumulated, right? And kind of like trying to see how that could be useful for the current task, which is learning to drive, right? So it's kind of like one instance of what you have learned in the past, you're kind of like trying to make use of it for the current thing that you're trying to learn, right? So that's very different from how machine learning is done right now, right? So right now, you're just kind of like, if you're learning to drive, you will get some label data set only for learning to drive, right? There is nothing else around, and it's very insular in some sense, right? So which is what we are trying to go away. And then also we kind of like, tend to learn easier things first and then move on to more complex things, right? So if you are, say, learning how to, if you're learning a new language, right? What do you do first, right? Do you pick up a novel in that language and start learning, right? If you don't know even say the characters in that language? No, right? So what do? You first, like, say, read about characters, right? What are the vowels, consonants, and all of that. Then you say, like, try to learn about syllables, words, sentences, like, paragraphs, kind of like build on your skills, right? Once you're competent into in some more atomic concepts, you use those competencies to learn more complex things, right? So there's a technical term for that, which is called curriculum learning, right? So in curriculum also you learn like the basic concepts first, and then you learn more advanced concepts later on, right? So the idea is to simulate that type of learning here as well. And also the more it learns, it should become a better learner, right? So as say probably, yeah, so like, if you have more context, more knowledge, then you should learn better. And also it should learn from experience and advice, right? So maybe it will like, interact with the world, make mistakes and learn from those mistakes, right? And also if there is some advice or teacher who is giving some feedback to that system, it should learn from that feedback as well, right? But we should realize that, it should not be spoiled by relying on lots of feedback from external sources, because getting good quality feedback is very expensive, right? We have access to our teachers, but they're there with us only for a limited period of time, right? And like, so we should like make best use of the human feedback that we are getting, right? So this is kind of like a desired list of features we would like to have in our learning system, which goes way beyond what currently exists. Okay, so this is kind of like the desire for this new paradigm, and the second part will be how we can use this paradigm to build this knowledge graph, which we have been motivating so far. Okay, so questions? No? Everything is very clear? Yeah, so all those things are there, right? So like, so for these tasks that we are trying to learn, these functions, their evaluation will be based on how well they are able to generalize, right? So the final evaluation remains the same, right? But it's just that like we are learning in a much more richer environment compared to like, the insular environments, how machine learning is practiced nowadays.
Basically looking for the solution for one specific problem. We are trying to generate or trying to get to a more general learning system which can do different tasks.
That's right, right? In addition to the ones that we are interested in. And the hypothesis is that like, if you learn in that type of a richer environment, you'll be able to generalize better compared to when you are learning in isolation. Okay? Yes? Right, yeah, so very good question. So reinforcement learning has some of these flavors, right? So it also tends to learn over an extended time horizon, right? But it still is usually in most cases is trying to learn one thing at a time, right? So you're trying to still say do one function approximation, but like doesn't have many of these other characteristics that we are talking about here, right? So maybe this reinforcement learning probably kind of like covers this first part, but like no, first point, but not of the other points that are listed here. But yeah, good question. Any other question? So are we all on board that like we need some richer learning system like this, right? Okay, so this NELL system is basically one instantiation of this paradigm, okay, which stands for never-ending language learner. And as I said earlier, the goal here will be to build this kind of structured knowledge graph by reading web documents on a continuous basis, okay? So what does NELL have access to? It has access to some initial ontology. So ontology is nothing but a bunch of predicates, right? And predicates are these categories and relations, right? So say person is a category, right? So city is a category. These are examples of unary relations or categories. And then a relation can be like a mayor of is a relationship which connects this person category with this city category, right? So it has bunch of access to those. It also has a few seed examples. So this is part of the supervision that the system has, right? So maybe it has examples of 5 cities, 5 persons, and 5 mayor of relationships, right? If those are the 3 things that we care about. And then it has access to the web. It can issue queries thanks to Google. It can issue like 100,000 queries per day. And it also has a locally indexed snapshot of the web consisting of about like 500 million documents, okay? Also, it has occasional interaction with human trainers, so humans can come and give feedback, like, whether a particular fact that's being learned is true or false, and things like that, right? So, given this input, the task is to run on a 24/7 basis, so which is kind of like part of this never-ending name, right? And then on each day, we want the system to extract more facts from the web, right? So the facts will be those edges in my graph, entity, relation, entity, if you're looking at, say, binary relations, right? And then as time goes on, we want the system to improve or at least not degrade in terms of performance, okay? So this is the input, this is the output that we expect, right? So any question about the input output? Yes. So why is it memory inefficient? Yes, but what's the way around that? Yeah, so like, I mean, if you don't know something, what do? You go and do search, right? So you get the documents, you retrieve the documents, you read from there, right? So it's following exactly the same process, right? And also, like, storage is cheap now, right? Hard disks don't cost much. So that's not a big concern right now. Yes. Also, how NELL runs. So it's basically a combination of two. So these snapshot of the web that I said, it basically processes those 500 million documents in a distributed Hadoop cluster, extracts some summary statistics from them, and then works with that summary statistics in a big server from that point onwards. So it's a combination of two. That's right, yeah. So because it's an iterative learning loop, so whatever you have learned so far becomes supervision for your next round of training. Yeah. Yes. Yeah. Right. Right. So very good question. So when you have limited amounts of supervision, once you start to learn something, right, the possibility of getting derailed and learning something completely different is very likely, right? And that problem is called semantic drift, right? And so previous attempts in building these kind of systems were kind of getting hampered because of those problems. But now, one of the enabling factors in NELL, which allows it to not have that type of semantic drift, is because you are learning all these different types of predictors at the same time, and then you are coupling all those predictor decisions, right? What do I mean by that? If you have a mayor of relationship predictor, right, which is going to take two strings and say string 1 is a mayor of string 2 or not. But you also know that this mayor of relationship, the first thing needs to be a person, right? Only persons can be mayors, right? So now you have a separate classifier for given a string, it will decide whether that string is a person name or not, right? So now what you do is you couple both of these two things together, right? So if this guy is going to say X is a mayor of Y, it better be the case that this person predictor also agrees that X is a person, and this location predictor also agrees that this Y is a location, right? So now if we hope that all these different predictors are not going to make the same errors, right? So now they can kind of constrain each other, right? So even if this middle guy is trying to go astray, these other guys will kind of constrain it, right? So which is the benefit for learning all these different functions at the same time and coupling, exploiting the couplings that exist among them, right? Because if you're just learning each one of these functions or predictors in isolation, you would not have this possibility of exploiting these couplings, right? Yes, right. Yes, so basically what happens is for say each one of these predicates, predicates are like categories and relations. There are like multiple algorithms that are exploiting different types of signals. Some are looking at free text, some are looking at tabular data on the web and things like that. So all of them make individual passes over the data and generate some candidates. Okay, so you get these candidate beliefs, and now there is a knowledge integrator layer which takes all these candidate beliefs and does some sort of joint inference to give you the promoted beliefs while making sure you are taking the confidences from these individual machine algorithms into account, or if there are some inconsistencies, right? So in many cases, if someone is a person, if X is a person, then X is not going to be, say, furniture, right? So it also does those kind of mutex relationships and all. And by doing some sort of constraint optimization to make sure things are consistent to some extent, it generates a newer knowledge graph in each iteration, right? And that new knowledge graph basically becomes the training data to train all these different algorithms in the next iteration, right? So that's how it kind of runs in loops.
The learner only be able to record facts, actually true facts.
Right, so factual facts, yes. Uh-huh.
Or people's beliefs or things like that. Anything available on the web is learnable.
Right. So some things are kind of black and white, and many things are not. Right. So one way to represent that will be you can store some context. Right. So that Bill Clinton was president of U.S. That probably is an unambiguous fact. Right. So everyone will probably agree with that. Right. But is sugar healthy? Right. Some people will believe that it is. Some will think it's not. Right. So you can kind of store those additional contexts, right? Now, who believes that that thing is true, and who you can put whoever else thinks that that's not true, you can put those contexts, right? Time is that way another context, right? Certain facts are true in certain times, but are not true in certain other times, right? So you can think of contexts are some ways to scope the validity of the facts. Depending on whatever the context is, right? So it could be sources, people, time, many different contexts are possible. I think there was a question, yeah. How do we? Constraints, yeah. So some of the constraints are specified manually when you are specifying the predicates. For example, if you have a relation biological mother, right? You know that physically only one biological mother is possible, right? So you say that that's a functional relationship. For each X, there could be at most or exactly there is one Y, right? So basically some of those things are manually specified. The system also learns some of the other constraints automatically, right? For example, say Virat Kohli plays for Team India, and Team India plays sport cricket, right? So if I told you about these two facts and asked the question, what sport does Virat Kohli play? What will you say? Cricket, right? So it can learn those kind of inference rules and kind of fill in the missing links, right? So those form additional coupling constraints in addition to the ones that we have said so far. Yeah. Yeah.
A has to be a person. Say A could it could be B, another person, right? That could also happen. How do you guard against myths or something like that?
So are you talking about the same string could mean many different things?
It can be a different person, or it could be a myth propagated. Like say for example, a person eats 8 spiders a year. It's a myth, but then it's propagated throughout the web, right? How do you guard against such facts?
Yeah, so say rumors and all. So rumors could be what you are talking about. Yeah, so right now there is no explicit provision because I would say most of the valid facts on the web far outnumber the rumors that are out there, right? And because this is kind of a first cut system, right? even getting like, we are even like way far off from getting even like the valid facts, right? And my guess will be like a tiny fraction of those are going to be rumors. So it's not a super concern right now, but like, as the system matures, we will have to look at those kind of issues. Yes.
Can it modify the knowledge that was learned in a previous iteration, given the fact that the knowledge gained in a subsequent iteration is built upon the knowledge in the previous iteration?
Yes.
But can this knowledge be altered? For example, if something is found to be wrong,
Right.
so can this knowledge be altered?
Right. So that's a very good question. And like, even though we are great learners, we also make mistakes, right? We learn something wrong, but over time, hopefully we correct those mistakes and kind of like move on, right? So NELL has certain capabilities. So even if it kind of like, learn something, it's not committed to it for the entire lifespan, right? So in fact, in every iteration, it spits out a knowledge graph. So all the facts that are part of that knowledge graph will have to basically kind of like survive like a test in each and every iteration, right? And if it has found like, if it kind of like learned a particular belief, but in subsequent iteration it figure out that there is like conflicting evidence to that, right? And those like far outnumber the evidence supporting that particular belief, so it's going to throw that particular belief out and kind of like, move on. So at any point there will be some mistakes, but it can unlearn and kind of like, can correct and move on. Right? But that's a very important skill, right? Because you don't want to get stuck with errors that you have made early on in your life. Was there a question at the back? No? Okay. So this is the input and output. So the where does NELL stand today? So it has been running continuously for more than 6 years now, or I guess like this is the 6th year. So January 12th is NELL's birthday. So if you are in IISc or in Bangalore, definitely stop by January 12th, 2017. So we celebrate the birthday by cutting cakes and all of that, and you're most welcome to join. Also, currently this is a little bit old figure. So it has more than 90 million candidate beliefs. So those are like the edges in the graph, and that's growing daily. So in addition to extracting this belief, it has the capability to do reasoning over those extracted beliefs, like that Sachin Tendulkar, or not Sachin Tendulkar, Virat Kohli example. I used to give the example with Sachin Tendulkar before, but now I have moved on, right, to Virat Kohli. So that's the reasoning example. And also it has the capability to do some sort of extension or discover new relations on its own. For example, at some point, it had learned a lot about rivers, right? So like, names of rivers and in what kind of context people mention river names. So one context will be, say, like, sat on the banks of, right? So after that, probably whatever is coming is going to be a river name, right? And it similarly knew a lot about cities, right? So the names of cities and how people talk about cities and all of that. So then it saw that, like, people tend to mention instances of these rivers and cities in sentences with frequency or probability much higher than random chance, right? So by analyzing the data again, it came up with this new predicate or new relation called river flows through city, right? So no human had provided that particular new relation, and that becomes a new learning task for NELL again, right? So like, I have to like find additional instances of that particular new predicate, okay? Of course, there's a bigger team behind. So here is a true fragment of the knowledge graph, which is extracted by NELL, where the nodes correspond to the entities and the typed edges correspond to the relationships that exist among those entities, right? So Toronto Maple Leafs, their hometown is Toronto, and they play sport hockey, right? And they happen to win the Stanley Cup. Yes. Colors? Yeah, so this is a node. Maybe I should have put circles. So these nodes are the entities, right? And these are edge labels, right? So like, hometown. The Detroit is the hometown of Red Wings. Any other question? Yes. statement with two different meanings, like? Okay. Okay, right. Yeah, so there is no support for metaphor right now, right? So it's kind of like naive in that way, right? Now, whatever it sees and reads, it kind of like just goes for the literal meaning, right? Yeah. But having built-in support for metaphor will be great, which is also like an active area of research. Yeah, good question. Okay, so you can go and browse the whole knowledge graph, like all the providence that is used to extract those at this URL, rtw.ml.cmu.edu, and RTW stands for read the web, right? And actually I may have a screenshot. Okay, so so basically so on the left hand side you see all these categories. Then if you click on relations, you will see all these different relation names, right? If you click on any one of them, you will get like lots of instances that belong to those relations. Okay, so right now there are about like 1,000 such predicates, categories, and relations, and each one of those predicates, there are about like 10 different algorithms that are working behind the scenes, right? So if you multiply 10 by 1,000, so total about 10,000 different learning algorithms are working behind the scenes to make this thing happen, right? And in each iteration, you are retraining each one of those 10,000 different algorithms to make the predictions. So I had searched for Nissan here, and then it kind of like said that Nissan is an automobile maker, right? And Nissan automobile maker. So you can go and give feedback here, thumbs up, thumbs down, and that Nissan makes the automobile Nissan Altima, right? So these are all automatically extracted by the system. And you can also see lots of provenance, right? Why it kind of like thinks that Nissan is a company, right? So one reason for it is that like in iteration number 622, it learned that like, there are like lots of web pages where there are these kind of like lists where like, Nissan is listed with say Honda and Toyota, right? And I happen to know already that Honda and Toyota are companies or automobile maker, and people will put things in the same list if they share the same type, right? So based on that, now it can infer that Nissan is also a company and also an automobile maker, right? So no one sat down and wrote like handcrafted like okay HTML/HAHREF, right? If you see that pattern, you do all of those things. So it's learning all those patterns automatically on its own, right? So it's not like handcrafted here. So yeah, so if you're interested, I definitely encourage you to go and browse through the knowledge graph. Right? Okay, it also has a Twitter account, CMU NELL. So if you are on Twitter, I encourage you to follow NELL at this handle. It also tweets from time to time interesting but sometimes politically incorrect facts, right? And people give feedback, right? We hope those are people, but I don't know, those might be like automated AI agents as well. But they give feedback saying like, hey, NELL, that's correct, or like, the stupid AI agent, that's wrong, and here's the reason why. So I think there's an interesting research question there. How do you model this conversation between an AI agent and probably humans, and like, how humans in this social media setting can help improve the performance of this type of AI agent. So that's currently not exploited. Okay, there are other efforts that you may have heard of, like SciCorp or Freebase. So Freebase was acquired by Google. So these are user contributed, which means like, people sat down and type all the beliefs that's there. But scalability becomes an issue, right? So if you have like, your favorite new domain, which is not reflected there, so it's become hard to build a knowledge graph out of those. Yago is another effort which is basically trying to build this kind of knowledge graphs by starting from semi-structured information, like the Wikipedia info boxes that you see on the side, right? That box, or like this category information at the bottom. So this is very much Wikipedia-centric, Yago, okay? And then you have Google Knowledge Vaults, which is a Google internal project also inspired by NELL, which is NELL, and this probably is doing kind of like trying to do the most ambitious project of trying to go from purely unstructured data to structured knowledge graph, right? While the others are user contributed and starting from semi-structured. Okay, so if you're interested, I would recommend you go through this AAAI paper covering the NELL system, which kind of like documents some of the lessons learned, open issues in this line. And we also did some evaluation as part of the paper, and we find that with time, the size of the knowledge graph has increased, right? Not always uniformly, but there are kind of like, bumps here and there, but also that like, quality has not deteriorated, right? So over time, the system has maintained its quality and sometimes have even gone up. So which is really encouraging that like, this is primarily self-supervised system is able to learn about the world without degrading in performance over like, a 6-year period. This is about like 1,000 iterations over 6 years. Okay, so how much time do I have? 10 minutes? Okay. All right, so that's about NELL. We also did some, and we kind of like continue to do lots of work in that space. But I thought I'll just kind of like quickly tell you about like one application that we did in kind of like this kind of like large scale text analysis. So all of you have probably used social question answering platforms, right? Like, Quora, Reddit IMAs, right? Stack Overflow, and there are like lots and lots of such examples, right? Everyone has benefited, right? Yes. How many of you have posted questions? Okay. Did you always get response? No? Right. So this work is trying to help you to get response, right? So, like in many cases, there are like lots and lots of questions like which get answered. In this particular case, someone asked on Reddit, what's the recipe of the White House's beer? And none other than President Obama came to respond to that particular question, right? But then there are some poor souls, right, who are trying to get some prologue questions answered, but there is no one to respond to that, right? So we are interested in analyzing why certain questions get answered, right, while certain other questions don't get answered. What factors are responsible behind these kind of distinctions, right? With the ultimate goal that, like, if we understand the factors behind, why particular questions don't get answered, maybe we can help the person who is posing the question to reformulate so that, that will elicit some response from the people. Okay? So, one challenge here is that there is no upfront classification of types of questions, right? So, we don't know how many different categories of questions are there, and even if we knew how to, map this question to these kind of different semantic types, right? So, something like this is syntax error related question, and this is kind of some output semantics related questions, right? So we don't have that kind of a classification to divide these questions into, right? So how can we kind of automatically discover that? So we are running out of time here, so I'm not going into details of all of these. So we just did some sort of matrix factorization to do these kind of groupings. So if you're familiar with topic modeling, right? So this is one way to do topic modeling, but we found that standard methods of topic modeling wasn't giving us this grouping of questions which are interpretable, but this kind of non-negative matrix factorization type of methods was highly effective in giving us groupings of questions which kind of have some sort of inbuilt coherence among them, right? So here it might be these group of questions are advice seeking, but the same can't be inferred about these automatically topic modeling based questions. But anyway, so what we did was we basically looked at different categories of questions, like, which are say posted to actors. So this is from a Reddit IMA data set. How many of you are familiar with Reddit IMAs? Okay, so there, what happens is celebrities or well-known people come to answer regular people's questions, right? And lots of people pose questions, and that celebrity can decide which questions he wants to answer and which questions not to, right? So that's a very good setting for us, because now you have like one responder, and we can control for the response rate for that particular responder, right? So we looked at multiple different domains, like say for actors, they tend to respond to about 5% of the questions that are posted to them, right? And now, by using these matrix factorization techniques, since we were able to get these groupings of semantically related questions, now we look at what particular categories of questions get response much higher than 5%, right? So this is about 16% compared to 5%, and what other categories get much lower than 5%, right? And now, because these groupings are interpretable, now we find that if you are asking questions to actors, if you praise them and say you are a great fan, start with those and then ask the question, it's much more likely to get a response. Or if you ask them behind the scenes, right? Okay, I really like that particular scene. Can you tell me what was the behind the scenes story? We saw that they're very more than willing to answer those type of questions. But don't ask Amir Khan, who is his favorite actress, right? So they want to avoid these kind of real life or preference probing questions. Okay, their response rate is much lower. So one lesson here is that if we have these kind of interpretable ways of grouping things, then we can do lots of interesting analysis of these types, right? So these are kind of some of the latent factors we would have liked to discover automatically, so that we can help people. If someone is trying to probe this kind of favorite posing questions to an actor, probably we can say that's not a good idea, right? So ask something else, or maybe reformulate it differently. Okay, so that's just one example, and if you're interested, we had a paper in ICWSM this year, so you can go and read more about it. So in NELL lab, we basically work on lots of things in and around knowledge graphs. So it's probably not a good idea to go into many of these different aspects, but just kind of lots of active work. And even though we are a relatively young lab, about year and a half, but people who have graduated have gone on to many interesting places, well-known places in industry like Google, Samsung, Microsoft, but also gone on for higher studies in well-known places abroad. Okay, so we also have some connections to neuroscience, but in the interest of time, I will not get into those. But the idea here is that rather than doing brain imaging data analysis of that in isolation, if you also combine these kind of large-scale text analysis together, you can answer even interesting questions in neuroscience, which will be hard to do if you are looking at purely brain imaging data. So we have some collaborations in the neuroscience department here, so we continue to explore that line. So in terms of courses, so I covered natural language understanding course here, and also a new course called Scalable Systems for Data Science, which is trying to bring together large-scale systems aspect and how you can use those kind of platforms to do large-scale machine learning, right? And this is a very unique course, the only one like this, which combines both systems and data science aspects, is actually just one I know at CMU, and apart from that, nowhere else. Also, natural language understanding is a really active area of research, and I'm just kind of putting some quotes by well-known people. So Michael Jordan, who is not the basketball player, but he's a very famous machine learning scientist at UC Berkeley, and someone asked him, if you had $1 billion, what will you do with it? And his response was, I'll set up a NASA-sized program for natural language understanding, right? Also, Google's senior vice president, who is actually their AI chief, so according to him, understanding language is the holy grail for machine learning, right? So, if you are either directly interested in language, or if you're interested in machine learning and machine intelligence, so language data provides you a very fertile ground, to kind of as an application of machine learning, but also to innovate and develop new learning techniques, right? So I just want to highlight that. And we continue to have strong external collaborations with places outside, in particular with the machine learning department at CMU. And we have lots of strong collaborations with industry, like Google Research have been very actively supporting our work right from the beginning, and many others. Okay, so as final thoughts, how many of you have heard about IBM Watson? Right? So yeah, pretty much everyone, right? So, so Watson is, for those of you who are not familiar, so this is a system developed by IBM, which went on to beat humans in the game of Jeopardy, right? And so if this were, as a precursor of things to come, and availability of all these large data sets, so we truly believe that we have an opportunity to go from these big text data to big knowledge graphs, right? And through which we can overcome this knowledge paucity problem, which has plagued AI and machine learning systems all along, right? And this seems like a good time to bridge this gap because of the availability of three things. So one is, first of all, we have the data, right? So earlier, data didn't exist. There is no point if you have big data and only your laptop, right? So we also have large-scale computing to churn through that data. And the third is the availability and advances in statistical and machine learning algorithms to derive insights and inferences from, right? So if you think about it, nowhere in human history, all these three things came together, right? At one point of time. So we are really excited to be working at that intersection, and our work spans machine learning, natural language processing, and large-scale data analysis. And through combination of all of these, we want to have an impact on non-trivial decision making. So if you're interested in learning more, I encourage you to go to our lab homepage. And so I believe there are some student demos which will happen tomorrow, right? So it happened? Oh, okay. So did they show? There are a few more. Okay. So yeah, so I guess my lab's demo is going to be tomorrow. So some question answering, science question answering systems that we had built. Just as a wrap up, this intersection is really an emerging area of research, right? And there are lots and lots of open questions. And one really thing that I like about it is it touches many different areas of computer science, right? So if you're interested in theory, large-scale systems, learning, language, right? You can just name any area. You can probably find many interesting topics to work here, right? And so if you're looking for areas to work for in, for your BTech thesis or later on also, I hope you will give this area consideration because there are lots of interesting things to be done, right? So, so there are a lot more things to talk about, but in the interest of time, I'll stop. And I hope to see some of you at least, as students and collaborators right here on campus. Okay, so I'll stop here. Thanks for your time. And if you have any questions, I'll be happy to address them. Yes. Yeah. Right. So there are some ways to normalize that, right? So also there are certain tools to handle those kind of, I would say, syntactic changes, right? But the real challenge is in the semantic space, right? Because there are so many different possibilities, and we don't have good tools right now to handle the semantic ambiguity. Good question. Anything else? Sorry?
Is there language independent?
So most of the components are not very much language specific. So initially everything was language, English focused, but there is another version which is Portuguese NELL, which was basically the same system was basically ported to Portuguese and run over Portuguese data. So that's running with some collaborators in Brazil, right? So that way, at least there is one instance where it has been easily ported to another language. So it should be, but the problem is we don't have too much data in Indian language, right? So here we have like 500 million documents, like access to the web, but currently the state of things are like it's kind of like data hungry. So you need like a larger corpus to read from, right? So if you have that kind of data, that'll be, I think, certainly applicable. So as one project, we are actually thinking of developing an India-centric NELL, right? So where it will kind of like encompass entities and relationships that are important from an Indian context, right? That's still going to be English focused, but like Indian English data. Yes. Yeah, so NELL itself is, I think, primarily Java. Yeah, Java and shell scripting, maybe some amount of Python as well. Okay, so thanks again. And I think I took time from Siddharth, so sorry about that.